I'm going to explain about the new experimental setup that we are already developing in our laboratory, so-called hybrid microgrid test setup. I will explain the main components of this experimental setups and the main purpose of from developing this actually laboratory, because it's not possible to ask you come by one here. Then I try to make a movie, and I will explain what we have here, which I think is very useful for those students who are working on basically microgrid integration. So as we discuss about microgrid, so there are the various sources or resources, energy resources. So here where we have solar system, a solar energy. This is the solar actually uh, test room for solar panels, because we have test room for solar panels and also we have test system for solar cell, and these are they are different from each other. The solar panel here, and this is the actually artificial light that we have, which can generate a solar beam or light beam, very similar to solar rays, which in same spectrum, range, and length width. But of course the power is lower than the solar, the real sun, because I mean this light can generate maximum about I think 350. We can measure here with this solar meter, 350 watt per meter square, compared to the outside solar sun that we can get even more than 1000. And then because the temperature rises so fast and sharply, then we have two fans here just to cool down the surface. And there is you can see the cable. There is the surface temperature thermocouple that you can measure the temperature of surface temperature of this solar panel, which at the moment is about 50, because it's too cold here. Anyway, and then I have also, as I told you, the solar meter. I will turn. Why we consider this room? You can see it is covered by the reflective material, which increase the the performance, the quality and performance of the system. Then you can get more solar power in this room. That's so-called the solar panel test room. Anyway, and then here we have when you open the light, it's like this. Just turn on, and then we'll open during the experiment. We have dimmer here, and you can actually use dimmer to increase the the solar intensity. And then I just want to show that the maximum solar intensity that we can get here is about, as you can see here, is about 350 watt per square meter. And we plan to replace it with much powerful light, and we already ordered. Anyway, let's turn on the light. So here you can see the two cables. So this solar light is connected to our maximum power tracker system. This is the best actually system which is available in the market, and it's a hybrid controller, which means that you can also control the wind speed. I will explain about the wind system. And as you can see here, the solar panel, the battery, and also load. And the mechanism which is used here to control the maximum power is P&O, basically, which is one of the simple ones. Anyway, so we use this system, the solar panel and the battery. Here is the battery, and the battery is very small. The capacity is about 10 ampere hour, and this is 12-volt battery, which means that you will have 120 watt hour. Why we choose this small size? Because we want to see the charging and discharging. As I told you, that or maybe I forgot to tell you, the maximum power that can be generated in this setup is only 100 watt. So you can see the scale. And but the main purpose of this system is to get the accurate and precise measurement result, because we are using very accurate measurement system. And also you have this chance to change the main parameters like the solar radiation, and I will tell you about this very interesting setup that we have for wind turbine, which is the wind simulator system. And so let me explain about the system here. As you can see, this is the wind turbine, and we just remove the blades, and here you can see coupling, and then the shaft of this generator is connected to this driving motor, which is the Mitsubishi motor, and this driver also connected to VFD. This is variable frequency device, and then you can change the frequency. By changing the frequency, you can apply different RPM to this motor, and then you can get output from the wind system. And the wind system, as you know, is the 3 phases AC current. So we have some special measurement system. We use the inductive current clamp here, and then so we have the same clamp for battery and solar system. And then you can see the connections here, that is for voltage and also for wind system. All of these connections are coming to this 4 data loggers, and these 4 data loggers are connected to the central data logger, and this data logger is connected to the PC with the software. So finally you can see the result on this monitor, the detailed measure data on voltage, current, and the power. Okay, so again we have wind turbine here, and we have solar panel there, and here is battery, and this is our load system. This is the DC electronic load, which is a programmable system, which means that you can simulate the real load. Okay, so to test the system, I just consider as you can see a 24 hours load, but I try to reduce the load to because the real load is very high for one standard house. I just try to scale down to make it possible to use it in this experimental system. So you can see we have 24 hours, and this is the basically the power that you expected in each hour, and each hour is considered 10 seconds because we want to short this experiment. So you can see from the midnight, so here the first, for example, 12 a.m., then we have very low voltage, and then the power, and the power increases step by step to noon time, and then to afternoon we have the great peak around 6 to 7 and 8 p.m., and then we have decline. So this is the real simulation, and when I start to the system load, it will start to apply this load to the microgrid system that we have here, and then we want to see how the integration between battery and wind and solar panel can help us to actually to meet this demand requirement. Okay, so then let me show you one simple experiment here. I just start the measurement, so you can see the load profile here from 12 a.m. midnight, and then the second hour. So you can see how the battery is discharged here. The orange shows the battery, and the green red is for load, and you can see current, voltage, and power, and also state of charge of battery here. Of course the state of charge decreases because battery is discharged, and so of course the output power from battery is much higher than load because of the efficiency. So this is a dynamic and real-time measurement system that you have here, and then also it's time to start the solar panel. So we start solar panel here with very low light, and then so you can see it's about very low, it's lower than 50, and then you have solar here. The maximum power is 2 volt, and now it's 8 a.m. Let's increase the radiation, so do maximum maybe. You can change it like as you want. And then now we have 325 watt square meter, and this is the temperature. It's about 26, the surface temperature, and this shows the purple curve shows the solar, which is much higher than demand. Then you can see how the battery is charged. Now the battery is charged. So the battery is positive, the power is positive, it means the battery is charged, and the total power from the solar panel is 15, and the demand is about 10. So we have charging during the noon time. Okay. So let's see, time is 2:02 p.m. Then I try to decrease the solar. Very low, and then again you can see the solar decreases, and I want to start and to run our wind turbine. So the total frequency is 21. Let's turn off the solar panel because now it's evening, 6 p.m. and the wind is coming. Yeah, here. Even we can measure the wind speed. Estimate the wind speed based on the detailed technical parameters. So you can get 17 watts from this wind turbine. I try to increase now the wind is increases. We have windy night. Yes. And now it's 8 p.m. The maximum load here. You can see 50. And now you can see battery is also discharged. This is because we have a dummy load here, and part of this power from wind is going to dummy load. It's very difficult to adjust the exact power from wind. So what's happened if I actually reduce the wind speed, I mean the wind power, and there is no solar, of course. We have wind and battery and load. And load is 50 now, okay? So when we go to night, 9 a.m., I try to turn off the wind. There is no wind. And now the fight is between the battery and load. So battery is discharged sharply because load is of course higher, and there is no wind. Look at the SOC is very low. It's very low, and there's a big question if we want to continue with the system like this for next day, then how to charge the battery. That's you need to consider emergency system. But of course it depends on the weather condition. So anyway, the measurement was finished. So let's look at the chart. Yeah, this chart is really important, which shows how the you can see a red line, actually area shows the demand, and the yellow one is for battery, and the purple shows the solar power, and blue is wind. And that's very nice. Then you can see the combination of different actually power sources to satisfy your demand. And this curve also is very important, how the SOC of this system decreases. And it gives you very important information for the next day, and you need to make your plan based on this SOC value, because the value of SOC is very low. So we need to consider additional source like diesel generator, or in the future I will explain about a new system that we have, fuel cell.